Okay, design plate number 2, online submission bukas. Then yung hard copy ay sa next face-to-face meeting na lang natin. So wag niyo nang dalhin sa faculty room. At ang next face-to-face natin is even week. So October 27. Ang mangyari is bukas pa rin yung pasa sa online, pero October 27 yung pasa ng hard copy. Kasi nakakaya din na magpabala pa ng faculty dito. Tapos, isip pa ako, may announcement pa. Wala lang maisip. Pero later, pag meron. Hey, so today ay bagong topic tayo. Velocity analysis using relative velocity method. So we have already covered the other 3 methods, which is resolution and composition method, instantaneous axis of velocity method, centro method, and now we are going to the last method, which is the relative velocity method. So, the relative velocity method is also the same method that is used in acceleration analysis. That's why it's only one discussion only. So I will just give you examples on how to do it. So we'll have a recap later for the other 3 methods. But for now, I'll show you the lecture of the relative velocity method.
Ay, wala nga pala dito.
Kahapon may singing contest daw yung faculty. Kasi Teacher's Day. Kaso wala ako sa school. Hindi ako nakasali. Kaya naman. Nanood ba kayo nun? Mga faculty kumanta. Tado tuloy yung MA. Panalo saan ng MA kung akong pinalaban dun. Joke lang. Wala eh. Pang weekday people lang pwede sumali. Nasa Manila din ako kapon. Sayang nga, Neil. Dahil, alam mo yun, parang 1,000 yung price nun eh. Eh, ano ba yung 1,000? Siyempre, papamalinda ko na lang sa inyo. Ilan kayo? 48. Ano, 1,000 divided by 48? Kano yun? Tigba 20 kayo? Anong mabibili nun?
4 na kwek-kwek, sir.
Ano yan?
Tiga-4 na kwek-kwek.
Pwede na nga rin. Kung gusto mo, padamihin natin. Fishbowl natin eh. Meron mag-fishbowl sa labas ng gate, di ba? So, ito, 1,000. Pag sinabi nila, ginto sila, yan, libre mo yan na. Nakapadlock ba? Okay, anyway. So for the last method for velocity analysis, we have relative velocity. And as I mentioned on the first part of the velocity analysis, I think this is the easiest method. Pero siyempre, ako lang yun. So relative velocity meaning the velocities acting upon a body are related to each other. Medyo mahaba lang yung paliwanag nito. Pero ibig sabihin lang nito, it's like vector addition. We will make what we call the the velocity polygon. And through that, we will get the velocities of the other points. So you will see again this equation which already been oriented to you in the topic of vectors, that there are the components of vectors are related to each other, and it can have an resultant. So for this one, this is only an example of the lecture that for every movement of a person, of a man, velocity of a man is relative to the velocity of a car. So this is an example, but I don't want you to focus on this example because this is example that a car is in a train. A man is in a train. And in this book, they are referring to a car at a train as a car. Ibang bansa ganun eh. Parang yung pagsunod-sunod na yung train ba. Imbis na yung train 1, train 2, car 1, car 2. Yan. So meaning, for the movement of a car, is a vector. And a man is walking inside. So imagine, hindi naman talaga siya car kasi anong car ba yung makakapaglakad ka sa loob? So the velocity made by the man is relative or related to the movement of the car. So their movement is influenced by each other. So meaning, if they are related, we can have a relation on that. So that's why we can make a polygon on their vectors. Meaning, if we have a mechanism where we will have to find various velocities at different points, meaning their velocities are related to each other. So we can make a polygon of their vectors. Again, when we say relative, it means that the vectors acting on a body is related to each other. So, for example, this one, if we have figure 4-22, yan, ito patatas na to, kunyari umikot. And ito ikot nyo. If this irregular shaped link is rotating at an angular velocity omega or small omega, clockwise at its joint Q, its pivot at Q, there are 3 points of interest, point A, point B, and point C. So for the earlier methods that we did, we can use instantaneous axis of velocity method to determine the velocity of C, B, and A if one of them is given. But for this example, we can use the relative velocity method and we can use what we call the velocity polygon. So the triangle of vectors that you can see here is what we call the velocity polygon. Meaning, we can derive the vectors of these points using this polygon. The question is, how do we make this polygon? Di man nakalagay pala dito. So the first step of a relative velocity method is to identify this small q. So this is a lowercase q. This small q is the representation of this uppercase q. We will place this small or lowercase q anywhere we want around the figure. For this example, they chose the q to be placed here. Then we will just make perpendicular and parallel lines. So how do we do that? From this q, if we are to determine A, we will connect uppercase Q with uppercase A, and we will make a perpendicular line going to A. Then, if velocity of A is given, if the length of the vector of velocity A is given, we will copy it, this length, to this one. Meaning vector VA is equal to this long vector. Yeah. So that's the same length. We will just copy it. Then let's go to B. For B, we will connect it to Q. Again, let's make a perpendicular line. So Q and B is here. Then from Q, make a line that is perpendicular to Q and B. And this is now D. If B is given, we will just copy the length of this velocity B. You just measure it with the ruler and copy it here on the velocity polygon. Then for B and A, we have to connect B and A. So B and A, this is the line. And we connect B and A. Let's make a perpendicular line to B and A. I will demo this later again for you to better understand, but I'm just giving you an overview. So once we have the polygons, we will now have the velocities. Another example is this one. Again, if we have a Q, we'll make a lowercase q, just like this one. Then we'll just copy the velocity A. So to get the velocity A first, let's connect Q with A. And let's make a perpendicular line going to Q. Then this perpendicular line, we will copy the length of this VA to this one, to QA. Once we copied it, let's now determine B. So Q and B, let's make a line. Then let's make a perpendicular line. Then we can copy B if it is given. If it is not, we will make a intersecting lines. So we will connect A and B, then make a perpendicular line that will intersect vector A, then the intersection of Q and B, then their intersection will be the end of vector QB. I'll make a better demo later. Okay, so this is another example of a velocity polygon. I'll show it later. Okay, I'll just open my handy dandy notebook. May nakapanood na ba sa inyo ng Joker? Maganda ba yun? Parang gusto ko siyang panood din eh. Wait lang ha, nahanap ko yung figure eh. Ba't nawala? Mm-hmm.
Pasok muna.
Nainip na ba kayo? Wait lang. Okay. Tabalikan natin yung example. Mahina ba yung audio? O okay lang?
Okay lang, sir.
Lo, wala nang sumagot.
Okay lang po, sir.
Okay. So, dito ay recap lang natin yung mga dating method. So, first, the resolution and composition method. For example, we have a given vector. Yung vector natin is at A. And i-determine natin yung velocity B using A. Ang gagawin natin sa kanya, i-connect natin si A kay B. Then, using resolution and composition method, itong A na to, hahanapin natin siya ng components. Gawa natin siya ng component here na perpendicular. Gawa natin siya ng component here. Then, ikakopy natin yung component na to dito kay B. Kung gaano siya kahaba. Then, gagawin natin siya ng components din na perpendicular. Though hindi pa natin siya alam gaano kahaba. Pero alam natin na ang direction ng B is parallel to the ground. Kaya gawan lang natin siya ng horizontal line. And yung intersection nila dito, this will now be vector of B. So this is the resolution and composition method. For the instantaneous axis of velocity method, we will have to determine the instantaneous axis. So for this, since we have A, given yung direction ng vector, we'll just make a perpendicular line that is here. Then another perpendicular line, since the direction of velocity B can be assumed, And since point C is on the same link as A and B, we can make we can use the same instantaneous axis. And this is point Q. This is the instantaneous axis. Then we can just copy the vectors. For this example, we can copy vector B. So let's measure from Q going to B. It is 1, 2, 3, 4, 5, 6, 7, 8, 9.1, 9 point, wait lang, 9.2. Then I'll copy 9.2 here. One, 2, 3, 4, 5, 6, 7, 8, 9.2. Meaning B is also here. So what I made is, if you have a compass, you can use a compass. We can make an arc here going here. Or if you have ruler, just measure it. I measured this to be about 9.2 centimeters. So I copied 9.2 centimeters here. Then we'll copy the vector. The vector of B is 3.7. So we just copy 3.7 here. One, 2, 3.7. This is now velocity V. It's just the same as the first velocity. Then, we will make a proportionality line. We will connect Q going to the end of vector B. Then from C, we'll just make a perpendicular line going to the proportionality line. This is now velocity C. So this is velocity analysis using instantaneous axis of velocity method. Then we have the other one, the centro method. So for centro method, we need to identify the number of links. So we have link 1 for the ground. We can say this is link 2. This is link 3. This is the slider is 4. And this is 5. Then this is 6. So this is a 6-link mechanism. So to determine the number of centros, we have n times the quantity n minus 1 over 2, where n is equal to 6, where 6 is times 6 minus 1 over 2 is equal to 15. So we can determine up to 15 centros for this figure, but we'll use only what we need. So for this one, to determine velocity d, we need to identify centros. So we have here 5, 6. Then we have 1, 6 approaching infinity. This is 1, 6 approaching infinity because it is on a slider. Then we have this is 4, 5. Okay. Then velocity at 4,5 is equal to velocity at C. Kasi pareho lang naman sila. Pareho lang sila ng point. Pwede kong gamitin to sa velocity 4,5. Then, uh, this 4,5 para may sentro. So basically, ano pa bang sentro meron tayo? We have, I'm looking into using this. But, hindi ko pa na-determine kung nasan siya eh. So anyway, somewhere here, mahanap natin yung sentro niya. So pag gagawa tayong sentro, first we determine the centro. So we have the common points on the two links. We have approaching infinity if it is on a slider. Ganun din dito, we have 1, 2. We have 2, 3. We have 1, 4 approaching infinity. So this is the same line. We have 3, 4. This is not 4, 5 pala. Ito pala 3, 5. Then, this is the centers we have identified using observation. 1, 2, 3, 4, 5, 6, 7. So how do we determine the other centros? We use what we call the centropolygon. So for the centropolygon, let's just trace the polygon based on the centros that we have already identified. So we have identified 1, 2, 2, 3. We have 3, 4. We have 4, 5. We don't have 4, 5. We have 1, 6. We have 5, 6. We have 1, 4. 1, 2, 3, 4, 5, 6. It's 1, 2, 3, 4, 5, 6, 7. We have 5, 6. 1, 2, 3, 4, 5, 6. We have 2, 3, 3, 4. Ba't ako'y naduduling na? 1, 2, 3, 4. We have 3, 5. Yeah. So we have this centropolygon. So next, we have to determine the other points that we can use to determine the velocity C. So velocity D. Velocity D, it concerns 5, 6. So let's figure out triangles that have 5, 6. So 5, 6, we can connect 3 and 6, I think. Oh, shit. Wait lang. So for 3, 6, we have 3, 5, 6, and kulang pa. Hindi pa natin magawan siya triangle. How about 2, 5? We have 2, 5. So, wala pa rin siyang triangle. About 1, 5. Pag 1, 5, 1, 5, 6, kulang pa din. Ang hirap naman ito. We can have 1, 3. So, sa 1, 3, we have triangle 1, 2, 3, and 1, 3, 4. Okay, let's start with that. So, triangle 1, 2, 3. And 1, 3, 4. During exam, you can bring different types of colored pens or pencils if it will help you identify or draw the figures. Excuse me. Okay, so now we have 1, 2, 3. So we have centro 1, 2, 2, 3, and 1, 3. So let's connect 1, 2, and 2, 3. So 1, 2, and 2, 3 is this one. Let's just make a line. Then 1, 3, 1, 4, and 3, 4. So 1, 4 is this one, 3, 4 is this one. Okay, so ito na rin yun. So ito ating centro 1, 3 is yung Q na rin na nakita natin kanina. Okay, so this is the same thing as this Q. Because triangle 1, 4, 3, 4, 1, 4, 3, 4. So 1, 4 is on a slider and 3, 4 is this point. So let's just make a vertical line going there, and their intersection will be 1, 3. Alright. Then, let's make a triangle for 2, 4. May magawa ba tayong triangle? Meron. So when I make centro 2, 4, you will have triangle 2, 3, 4 and triangle 1, 2, 4. 1, 2, 4. Okay. So we have centro 2, 3, 3, 4, and 2, 4. Let's make a line. 2, 3, and 3, 4. Ayan. Gawin na natin siya ng line. Then we have 1, 2, and 1, 4. And 2, 4. 1, 2 is here. And since 1, 4 is approaching infinity, we'll just make a straight line from 1, 2. Then their intersection will be 2, 4. But we still cannot use 2, 4 for 5, 6. So let's look more. Ano pa ba ang pwede? Okay, let's try 3, 6. So for 3, 6, we will have the triangle 3, 5, 6. Then, we have 136. May nagtanong sa akin last lecture, pag po ba nag-drawing ng polygon, pwede ba yung solid line? Kasi puro broken line yung ginagawa ko dito eh. Oo, pwede naman. Yun naman ay para sa akin, mas maaalala ko siya pag ganyan. So para sa kanya, pagka nagamit niya na siya, gagawin niya solid line para hindi siya malito. So it's okay. You can do that. This is just the presentation. So we have for 356, 35 and 56. Let's make a line. 35 and 56 is here. Then we have 1316. 13 and 16. So 13 is here and 16 is infinity. So we can have 13 here. And 16 is approaching infinity. So this is also 16. So their intersection is now 36. But we still cannot use this instantaneous axis. Isip ko paano ko magamit to. Okay. Let's look for others pa. Siguro yung magagamit yung 1656. So we can have 15. Yung 15 kasi so kulang pa. Kasi wala pa tayong 45. Yung 45, paano ba natin gagamitin siya? 4, 5. Pag kinanek natin si 4, 5, ano ba to? 4, 5. 3, 4, 5. Tsaka, wala. Pag 4, 6, ay mabubuo tayo triangle. So, 1, 6. Pag ginawa natin ito si 1, 6. So, meron tayong triangle 1, 5, 6. Tsaka triangle 1, 3, 5. So, let's draw that. Triangle 1, 6, 5. Tsaka 1, 3, 5. Hindi naman siya. Okay. So sa 1, 5, 6, we have 1, 6 and 5, 6. Ito na yan. Then, we have 1, 3 and 1, 5. Ang 1, 3 natin ay ito. Ang 1, 5 ay ano ba ang 1, 5? Wait. Ay, tama. 1, 5 pa lang hinahanap natin. 3, 5 pala to. Yun. So, 3, 5 ang hinahanap natin. So 3, 5, and 1, 3. Yan. Mag-intersect sila. And ang intersection nila ay sa 1, 5. Meaning, ito yung 1, 5. And this 1, 5 is a centro that we can use to determine velocity D. So, meron pa tayong centro 4, 6, meron pa tayong centro 4, 5 na hindi nahahanap. Pero pwede na natin silang hindi hanapin kung hindi naman natin sila gagamitin. So this, for centro 1, 5, pwede natin gamitin si C. Determine natin si C. Yan na siya kakalayo sa 1, 5. Siya ay 1, 2, 3, 4, 5, 6, 7.4. 1, 2, 3, 4, 5, 6, 7.4. Then, kung gano'n siya kahaba, let 1, 2, 3, 4, 5, 6, 7.4. Then, ang haba niya is, gano'n ba kahaba to? 1, 2, 3.3. Then we'll make a 3.3 here. 1, 2, 3.3. Then we'll make ito yung velocity 4, 5 natin na equal naman sa velocity C. So pareho lang yan. Then, alam natin ang direction ng G is going downwards because it should be parallel to the ground. And when we imagine that the mechanism is going to the left because all of the other vectors are going to the left, the tendency of the slider is to go down. So it's parallel to the ground and going down. And from centro 1, 5, let's make a proportionality line going to the end of vector C or 4, 5, and the intersection at this will now be velocity or velocity 5, 6. So this is velocity analysis using centro method. So the 3 methods I have applied here are the ones that we had lecture in the past. Again, we have resolution and composition method, we have instantaneous axis of velocity method, and we have centro method. For centro method, I first computed for the number of centros. Then I made a centro polygon. Then based on the centro polygon, I determined the locations of the centros because we will have to find the right centro as a reference point to determine velocity D. So now I have determined velocity D. Excuse me. Okay, for the conclusion of this example, we'll just have to measure the velocity D, the vectors of velocities, then multiply it with the velocity scale, kV. So we will have the actual velocity. So again, this is the 3 methods. Because now, I will show you how to determine the velocities using the new method, which is the relative velocity method. So how do we do it? Again, I think for me, this is the easiest method. But again, that's just me. So again, for example, we have link QA is rotating counterclockwise given this direction, and it is turning at let's say 200 RPM. Then link QA is given to be about 4 centimeters. Given. Meaning, sa exam, pag given na yung haba, huwag nyo na sungatin kung anong haba ng link. Kasi ganun nangyari dati. May sukat na ako nilagay sa given, pero sinukat pa rin nila ng ruler. So, dapat yung given ng manaig. So, if we will have to compute for velocity at A, we will have to determine it by computing for the linear speed from the angular speed. So, the angular speed is 200 RPM. If point A is turning, if it is circling around, it can make a circular path, meaning QA can be referred as a radius. So if we have to determine velocity at point A, we can use circumference times the angular speed, whereas the circumference is equal to 2 pi r, where r can be QA, and it is equal to 4 centimeters. Then, we'll just substitute. So, VA is equal to 2 pi 4 centimeters times 200 revolutions per minute. And since one circumference is equivalent to one revolution, we can cancel revolution. Then the answer will be 200 times 4 is 800 times 2, 1,600 pi centimeters per minute. Again, sa midterm exam, we will use whole numbers. So you will have to multiply the pi to 1,600. Then, let's set a velocity scale. So if we have a velocity scale, for example, we have for every 1 centimeter is we have 400 pi centimeters per minute. So if we will multiply the velocity with the velocity scale, we have 1 centimeter over 400 pi centimeter per minute. Cancel unit, cancel pi. 400 divided by 1,600 divided by 400 is equal to 4. Then it will be 4 centimeters. Meaning, we will draw 4 centimeters on this diagram. The velocity should always be perpendicular to the link that it is connected to. We have 1, 2, 3, 4. This is now velocity A, which is 4 centimeters ang haba. Now we have to determine velocity at B, velocity at C, and velocity at D. How do we do it? Using uh, relative velocity method. So for this example, we have 3 points at we have 3 ground. We have ground here at Q, we have ground here at B, and we have ground here at D. That's the assumption. Okay. So let's determine the small q. For example, we will place q here. Let's start with the point. So this is lowercase q or small q. What we need to do is let's make a perpendicular line going to this q with reference to A. So to do that, let's stretch out the QA line Then, let's determine the perpendicular line. So, since vector A is already given, wait, hindi pala kasi sa figure natin. Kasi ba? Kasi ibaba ko na konti. So, since we are determining A, we connected QA. To do that, we will have to make a perpendicular line going to this lowercase q, then measure 4 centimeters from it. One, two, three, eight. Okay. One, two, three, four. So this is VA. So this is just the same. This should be perpendicular. Again, what we did here is, since we are determining, we will put the velocity A on what we call the velocity polygon. We will make a point Q here, the lowercase q. Then we will transfer the vector of VA to this point Q. So to determine its location, I made a straight line going from the ground to point A. Then I made a perpendicular with the lowercase q, and I copied the length of vector VA. So at the end of this vector, I will label it as small a. Meaning, this vector is from A. So now, let's determine the vector of velocity B, C, and D. So to do that, let's look at the velocities. So for velocity B, we know that velocity B is horizontal because it is on a slider. We know that it is going to the left. So meaning, in the velocity polygon, velocity B should also be going to the left. So this is velocity B. So how do we determine the length of velocity B? We can use referencing for this one. So let's use A as reference. Let's make A and B. Make a straight line for this. Then, from A and B, determine a perpendicular line that will intersect the arrowhead of A. Okay? So this is the perpendicular line. Let's connect here with here. Yeah. So this is perpendicular. Then the intersection at the velocity polygon is now the end of velocity B. So ang bilis lang. Meron ka ng velocity B agad. Dalawang line lang yung ginawa. O, tatlo. So I just connected B and A because we know that the velocity of B is parallel to the ground, which is horizontal. So that's the first line. Then I connected A and B. Then I'll make a perpendicular line that will intersect the arrowhead of A. So this is now A and B. Wait lang, may nalaglag dito. Okay. Then for point C, point C is, oh, let's go with D first. So D is going downwards because it is on a slider. So from Q, it should also be going downwards. So for B and D, let's connect B and D. Then let's make a perpendicular line that will intersect point B. Wait lang. I think this is not pwede. We need to first find C. So A, B, and C. Uh-huh. We can connect B and C. But B and C is already on the same line. So, mhm. Nakalimutan kung paano gawin. Wait lang. Tandaan na talaga. Because yung C hindi naman na-connect sa ground ba? Mhm. C and D. Kasi for B and C, okay. So for B and C, we will make what we call the proportionality line. Because ABC is, what do we call this? On the same link. So meaning, small a, small b, and small c are also on the same line. So what we will have to do is use ratio and proportion here. So let's measure from point A going to C. So AC, let's make AB over AC. So for AB, it is equal to 1, 2, 3, 4, 5, 6.6 centimeters. Then for C, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.6. Okay? I'm just measuring the length. Again, what I'm doing is we will have to use a ratio and proportion because ABC are on the same link, meaning the lowercase a, b, and c are also on the same link. So AB, I will just double check the length. So it's 1, 2, 3, 4, 5, 6.6, and AC is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.6. Then let's measure the lowercase part. So we also have AD over AC, where AC is unknown. We have AD, which is um, 1, 2, 3, 3 centimeters. Okay, so if we will designate x pa din, the unknown as x, so we can have a proportion of 6.6 over 12.6 is equal to 3 over x. So if we will solve for x pa din, calculate lang. Hindi ko kaya mental math eh. We will have x is equal to 5.7. So we will measure 5.7 from A here. 1, 2, 3, 4, 5.7. This 5.7 is now our small c. Then we will just connect it from Q. And we now have the velocity c. So that's velocity c. So I used ratio and proportion because on link ABC means that on the velocity polygon, ABC are also on the same line. So they are the same. So we'll just use ratio and proportion to identify the location of the small c, and I just connected it with Q, and this connection will now be velocity c. Now for velocity d. So C and D are on the same link. Let's just make a straight line here. And we'll have a perpendicular line going to this straight line. That will intersect at C, the small c. And the intersection here at Q will be the end of velocity d. And this will now be our velocity d. So once we have made this velocity polygon, we'll just make a table here. So we have velocity b, velocity c, velocity d is equal to, let's just measure it. We have, for velocity b, we have 1, 2, 3, 4.6 centimeters. For c, we have 1, 2, 3, 4, 5, 6.4. For d, we have 1, 2, 3.9. Yeah. So once we have now the measurements, let's just multiply them with our velocity scale, which is for every 400 pi centimeters per minute, we have 1 centimeter. For every 400 pi centimeters per minute, we have 1 centimeter. And for every 400, yeah, tama, pi centimeters per minute, we have 1 centimeter. So let's just cancel centimeter, cancel centimeter. Then we'll have the answer of calcube. 400 times 4.6 is 1,845 centimeters per minute. We have 400 times 6.4, 2,560 centimeters per minute. And 3.9 times 400, we have 1,560 centimeters per minute. So this is our computation. We have now performed velocity analysis on this figure using relative velocity polygon. Again, the first step on placing this cube is crucial, and you can use anywhere on the paper. So to prove that, uh, let's make another polygon. And for example, we have Q here. If that is the Q, again, let's make a perpendicular line going to Q from A. So if we will put velocity A, let's make a straight line from Q going to A. So this is that line. Wait, burahin ko yung mga reference line para kunyari bago. Yan. So let's first make the line at QA to determine vector BA. I will connect Q and A. Then let's find the perpendicular line going to the small q. Okay. Then we will copy vector A. And since it is given as computed as 4 centimeters, we will put 4 centimeters here. 1, 2, 3, 4. So now this is velocity A. Now for B, since B is on a slider, we know that it is horizontal because the ground is horizontal. And we'll just make a horizontal line going to the left. And we don't know yet how long it is. We just know its direction. Now, let's connect A and B. We will put a small letter A at the end of the vector. This one, small a. Then, to determine B, let's connect A and B. So we will connect A and B here. And once we connect, we'll have to determine a perpendicular line going to A. And the intersection with the direction is now B. So this is B. Velocity B. I just made 3 lines. I already have the velocity. Not like resolution and composition method. Not like instantaneous axis of velocity method. Gagamit pa ng compass. Centro method, magagawa pa ng mga centro polygon, triangle. Dito sa relative velocity, ganito lang. Then, we have now B. Now let's determine C. So C is on a point, on a link with A and B. And on the velocity polygon, A, B, and C should also be on the same line. So I used ratio and proportion to determine the location of C. So we arrived at 5.7. So from point A going to, let's measure 5.7. 1, 2, 3, 4, 5.7. Let's say this is small c. Then we'll just connect Q and this point. Ito na yung velocity c. So tagalogin ko lang. Kasi sa link AB, kasama nila si C. So it's a link ABC. Kasi straight line siya. Meaning, dito sa velocity polygon, dapat magkakasama din siya. Kaya nag-ratio and proportion ako. Gaano ba kalayo si A kay C? Gaano ba kalayo si B kay C? Para yun din ang gagamitin kong proportion dun sa velocity polygon. Na-determine ko ngayon, nasan ngayon yung si small c. And we have velocity c. Then for velocity d, we know that it's going down because velocity d is on a slider and its direction should be parallel to the ground. So we just know its direction, not yet its length. And D is connected to point C. So we can use point C. Okay, so let's connect C and D. Then let's make a perpendicular line that will intersect small letter C. And their intersection will now be the end of point of vector D. So this is velocity D. So I just made 3 lines. I already have velocity D. And if you will compare this polygon with the one that we did earlier, it looks the same thing. So again, regardless of position of the velocity polygon, we will arrive with the same answer. Okay? So, tingnan nyo, magkaiba yung pwesto niya, yung pinagsimulan. Pero since we are using the same reference lines, pareho lang din yung makukuha niyan. And sa exam natin, ganyan ang mangyayari. I will give you a figure, then you will have to make velocity polygons on different locations. Sinasabi ko na pala yung nangyari. Okay. So then, final part, sukatin lang yung haba ng vectors. You just measure the vectors using our ruler. You multiply it with the velocity scale. And now, we will have determined the velocities at the different points. Again, for me, I think this is the easiest method in velocity analysis, but it's up to you. And if you will check it with the other methods, the answers will always be the same. So let's have one final example. Let's have one final example. Then, tapos na tayo. Bukas na ulit. Okay. For this example, what if we have velocity A as given, then determine the velocity of B, C, and D using relative velocity method. We will use polygons. Ilabas ang ruler. Okay. First, sukatin natin gaano kahaba ba itong given natin. So we have vector A is about 1, 2, 3.8. Let's first determine where we want to put Q. So for example, we want to put Q here. Then, wait. Pangga ba? Lagyan natin dito. Yeah. Then let's find the perpendicular line. Going here. Then let's measure 3.8 centimeters. We have 1, 2, 3.8. This is now small a, and this is now our vector for velocity a. I just copied it. Then let's determine velocity at b. So velocity at b, since it is connected also to the ground, we can determine its orientation. So let's just make a straight line from Q. Then let's make a perpendicular line going to small q. Then let's have AB. And let's make a perpendicular line going to point A. And the intersection here will be point B. You have velocity. Then for point C, we will have AC and BC. So AC let's have a perpendicular line going to A. Then for BC, let's have a perpendicular line going to B. Then their intersection will now be point C. Then let's just connect it to Q. And now we have velocity C. Then for M is in the middle or the midpoint of B and C. The meaning, on the velocity polygon, the M should also be in the middle of B and C. So for this figure, for the polygon, let's just measure B and C. Then its length is 1, 2.2. So meaning its midpoint is at 1.1. So this is the small m. Again, because this is the capital M, it is in the midpoint of CB. So in the velocity polygon, it should also be in the midpoint. So let's just connect it with Q. And we will now have the velocity at N. And finally, velocity at D. Here, we have velocity at D, which is in the same line as B and Q. So we'll just have a ratio and proportion again. So we can have QD over QB. So regardless of it has number because this has Q4, the other is Q2. But since this is ground, we can just disregard the number. But for uniformity, we can place it here. So Q4D. So this one is Q4D and Q4B. This one, the whole length. We'll measure it using our ruler. So we have 1, 2, 3, 4, 5, 6, 7.2. Then for QD we have 1, 2.35. So that's the proportion of that. Now let's measure. Let's just copy this one here. So this is QB. So for the QD is unknown. Then QB. The length of QB is 1, 2, 2.65, I think. So if we ratio and proportion this one, we can have it as x over 2.65 is equal to 2.35 over 7.2. We can determine 2.65 times 2.35 divided by 7.2. We have 0.86. Paano ko hanapin sa ruler yan? Galingan na lang. So, kunyari, dito siya. Yan. Ito na ang point D. Then, yung 0.86 na yan, ito na yan. Lagyan natin ng arrowhead. Meron na tayong velocity D. Then, we have, kompleto na yung ating polygon. We have VA given. So, we have VB, VC, VD, and VM. So, atin lang natin yung haba. 0.86. Then, centimeter. Then, B is 1, 2, 3. Then C, we have 1, 2, 3.7. Then, sa D pala yun. So, iba pa itong nasa ating M, which is 1, 2, Pareho sila. Ay, mali pala ang sukat ko. Ito ang 3. Ang B pala. So, 1, 2, 2.65. So, itong M na to ay hindi pa sa kabila. Then, ang B is 2.65. Then, pag may sukat na tayo, yan, multiply lang natin to lahat sa velocity scale. Meron na tayong velocity ng ating different points. Okay? So, that's it for our lecture. Sabi ko kanina, sabihin ko yung exam. So, ang exam natin is identification and enumeration. Then, may part doon na gagawa ng centro polygon. Then, hahanapin yung centros. May part din doon na may part doon na magko-compute ng mobility. Then, itong velocity analysis. So, kailangan may dala kayo na pang drawing materials, ruler, protractor, and everything. Yung ginagamit natin sa design plate. Kasi bawal maghiraman. Pag kasi nakita kayo naghiraman, ang gagawin ni Proctor, i-assume na nagagayahan kayo. So kapag ganun, mahirap. Kasi mamarkahan na yung inyong papel na cheating. Kaya, magdala na yung sarili niya. Okay, so given ang velocity scale, ang KV, whole numbers lang tayo. And I think yun lang naman yung exam. So, paano ba mag-aaralan yung exam? Doon sa identification, madali lang. Kasi doon sa terms naman na ginagamit ko, nandun naman yung madaling malaman kung alin yung mga terms na kailangang malaman. Any question regarding our topic and exam? 100 items. Kasi sadya bang walang grade pa yung design plate? Ang ginagawa kasi dyan ay kina-check ko din muna yung design plate later. Parang hindi ako ganun ka-strict sa pag-grade niya. So, para meron tayong paghuhugutan ng grade kung medyo alangan. Kaya sa design plate ko lang siya tinitingnan. Kaya pag midterm kayo, parang magkakaroon na kayo na idea kung sa midterm, mararamdaman nyo na kung anong standing niya. Then, ang pwede ko lang may makitang para hindi naman kayo mag-alanganin. Sa design plate tayo magtitingin ng grades. Okay? So, yun lang for today. Thank you for attending the class. Bukas, meet ulit tayo. Last class na siguro natin before midterm. And na-cover naman natin yung lahat ng topics for this half. Okay? Thank you.